Assalamu alaikum everyone, and today we are going to talk about conic sections. So since we picked up algebra a few days ago after we started trigonometry, we've picked up on polynomials. But now we have to, and sorry if you hear any noises, my cousin sisters came to visit, so sorry if you hear any noises. So like I was saying, we picked up polynomials. Now let's pick up on graphing. Now in our video on what are functions, we talked about that not all graphs are functions. Now if we apply that to something like a closed shape, then all of them will be disqualified. Now there are types of shapes called conic sections, and so let's graph them. But Uzair, I don't even know what conic sections are. Oh, well then, maybe I can help you. So conic sections come from a cone, hence the name conic sections. So if we have a plane directly perpendicular to the cone's altitude or whatever height, then you will get a circle. If the plane is doing the same thing but tilted, then it's an ellipse. This will be important when we talk about astronomy later in our future astronomy course. If we have a plane like around this, then we'll have a parabola and a hyperparabola here. So these are the four conic sections, and we can measure them by their efficiency. So we can measure them by efficiency, which is how close it is to being, how farther it is to being a perfect circle. Now a circle would have an efficiency of 0, since, well, it is a perfect circle after all. So like there wouldn't be any further. Would be more than 0 means the ellipse will be greater than 0, so it will be, at least a little less, but less than 1, so it's near a circle. A parabola and something like a hyperbole will have an efficiency of less than 1. Now this is basically the definition of all of them. Now let's graph them. Now since there are 4 shapes and each shape will need a lot of understanding, I'll make this a 4-part series, and in today's video we're gonna tackle circles, the easiest one. Then we're gonna tackle the more trickier and unfamiliar ones, like ellipses and parabolas and hyperboles. So let's graph circles. Now from our video, what is pi, we learned that circles are points that are equidistant to a center point, and the distance of the center point to one point will be a radius. So when we give our x and y coordinates, we can say the point of the radius is x comma y, and the center is h comma k. Okay? See what I did there? Now, how do we figure this out? First, what we have to do is with the distance formula. Yes, again, Pythagoras is back. If you don't know what that is, you just check my slope and distance video. So you just check my slope and distance video. Sorry if you hear too many noises. Again, my cousin sisters are here, and I'm sorry if you hear any noises. My cousin sisters are here, and anyways, back to stories. So in the distance formula, delta x and delta y can be, expanded to x2 minus x1 plus y2 minus y1. And this is the form we're going to use today. But instead of the x1 and y1, we're going to put h1 and k1. Now remember, it's exactly like this. So it won't switch. So like when we do some algebra, we can see, by the way, this is going to be the radius. We can see that r squared equals to x squared minus, actually we're going to not use the subscript, and so x minus h whole square plus y minus k quantity squared. Yes, whole square can also be described as quantity squared. So a form of this is the standard form of the circle equation. So something like y squared plus x squared equals to 9. The radius would be 9, obviously, and h and k would be 0, so it would be in the intersection, and y squared and x squared. And there we have it, a circle with the radius of 3. We can also check the equation by the graph. So here, h equals to -2, b equals to -1, and r equals to 2. So if we plug this into this equation, x plus 2 squared plus y plus 1 quantity squared equals to r squared. This will be the equation of this circle. I know I just exaggerated my voice a little, and that's only to hide my cousin sister's voice. So there can also be tricky equations. Something like x squared plus y squared plus 4x minus 6y plus 23 equals to 0. We just switched to 23. Then in a few videos ago, we learned how to complete the square. So we're going to use that, but twice, to, do the variables. Twice the variables. So we're going to put each variable exactly where they are. Now let me use another marker because this marker is running out of ink. So if we add 4 here, this will be a perfect square. Remember to add 4 to the other side. So this will be now x plus 2 quantity squared plus y squared minus 6y equals to 27. If we add 9 to the other side, then we get a perfect square here too. Y equals to 3 quantity squared, which here would be 36. And there you have it, the equation. The equation is now solved, and this is in the standard form. So with that being said, we understand about how to graph circles. Now let's look at another trickier variation of this, and that is the ellipse. So that's all there is to it. You can subscribe to my channel if you need any more math help or science help. Sorry for the burp. And thank you for watching, and I will see you next time. Bye!